Hey everybody, Dave Lindbergh in Hong Kong today with another episode of the THD Podcast, Total Harmonic Discussion. Episode 4 now. Today we wanted to go into a bit of discussion on battery and power management related to portable audio devices. You know, we got some expertise in headphones, but we wanted to go on some of the issues involved in that. So with us today, we have Simon in Japan, as always, and we can see a little bit of his test setup he's preparing for us. So, hey, Simon, how's it going?
Very good, very good. How about yourself?
Yeah, good over here.
Excellent.
So let's let me get into a bit of like what we're going to talk about. Bear with me. So in terms of portable audio devices or battery-powered devices, there's a selection. They're either portable small speakers or headphones. That's kind of the bulk of everything related to audio. You can get some weird things like shoulder speakers like Sony and Bose have, but for the bulk of it, it's mostly Bluetooth devices. But you're dealing with like Wi-Fi, some proprietary RF sometimes. There are some ANC, active noise canceling headphones, such as like Sennheiser, and a few guys still have wired headphones that have an additional power supply. And then there are also some fancy headphones with heart rate monitoring or biometric sensors. So those are the type of devices.
The biometric sensor stuff is sort of getting a bit more active, really, isn't it?
Yeah, I mean, there's all kinds of different things related to just heart rate, but also body temperature, and other types of technologies that they're weaving in by being able to pick up these things off of your either other types of sensors that pick up the feed. So it's all battery. And then just building on that. So in the everything involves the stack up, right? So is it the amplifier consuming a lot of power? It's the microphone. There's some cool new stuff from Vesper doing ultra low power microphones, especially if you're doing voice or other types of controls. These microphones have to be always on. So sleep mode kind of impacts things, and then always on power. Microcontrollers, you know, what kind of processing are they doing? Volume controls over an RF link, other types of processing such as digital signal processing. And then, you know, the RF, and that would include Bluetooth, Wi-Fi, or proprietary, and active noise canceling. And now there's also voice added to edge or portable devices, and even touch controls that will consume power from how they interact. And some of these, you know, cross over with each other. But in general, like a microcontroller could also be embedded into the Bluetooth and stuff like this. But in general, what you're worried about is the full stack up of all these things working together, and how do you minimize that for power. So that's just kind of like the issues involved. So let's just maybe, Simon, talk about your little demonstration you want to go through here on some different batteries powering a headphone, and also what you can.
Yeah, I pulled out a few different batteries, just as something to have a look at. So in a sort of an over-the-air headset, you typically get this type of a thing. So I'll flip around the other way so we can actually see. It's like 450 milliamp hours. There's a larger one if you can fit it in. Was that 900? And one of the things I was really interested in is, for a given size, what's the scope of capacity that you can get? And so just at a very cursory kind of a look at things, you say, well, you've got a certain volume, and the lithium technology is going to basically give you a fairly similar capacity for that volume. So it's just how much battery size can you afford to put in there? But I don't think that's quite all that true. There is actually quite a big scope for increased capacity for the same volume of lithium. Are you familiar with those parameters?
Yeah, I've got a couple things queued up at the end here to talk about.
Yeah.
Approaching different chemistries can support different capacities, but of course the stability of those chemistries is varied. And introducing new chemistry technologies is not something that happens overnight. So there's some things that have been working on for many years, but as we all know about the risk about shipping batteries and the exploding Samsung phones and stuff like that, chemistry stability is something that's critical before they start to launch new battery chemistries. But I'll touch on some ideas that are coming in the works at the end here.
So this is actually a typical battery that you get in a true wireless stereo earbuds. And so that is, what is it? 45 milliamp hours in that size. And I thought, okay, well, that's roughly what you're going to get. And we were doing a project at the moment, you see, and true wireless stereo earbuds. And we'd worked it out and said, well, we've got about a 40 milliamp hour battery, fairly much the same as this. And you work it out and you get 3 or 4 hours battery life based on that power consumption of those earbuds. And so then we're scratching our head thinking, that's not really enough. So I had a bit of a search on the web. You might have come across ifixit.com. And so they have one of these, an AirPods Pro teardown. And somewhere in there, they've actually got a circular cell, sort of like, it looks something like these button batteries, but of course the diameter is smaller and it's a bit thicker. And they had like 160 milliamp hours and essentially the same volume as this thing. So I've yet to figure out, is it a different chemistry or how are they able to achieve that? I don't know if you have any insight onto that.
Well, Apple would be using custom batteries. I believe Varta from Germany is their supplier.
It is, yeah.
So yeah, I don't know about using unique chemistries, but definitely like doing structures. So a lot of the batteries like you have in front of you, they're packs. So they're multiple cells that are just kind of packed together. But if Apple's able to order a specific size, maybe they're able to pack a custom dimension to get more out of the same bulk of size.
Yep. So there's the basic I just wanted to run through anyway is just to make it clear is you have this figure for a battery capacity. So this one, 450 milliamp hours. And they always talk about it in terms of milliamp hours or sometimes watt hours, but the milliamp hours is kind of a convenient way of talking about it. So then you can go and say, well, how many milliamps does the device draw at any given moment? And it will vary, but let's say, for example, if you had something that was drawing 450 milliamps, you could get 1 hour of energy out of that. So you just divide out by the current that you're using. So 450 milliamp hours at 450 milliamps of usage would be 1 hour, or half that. You get twice the time. So the capacity just equals the amount of time, for a given current draw equals the amount of time that you get out of it. So there's one facet of it is to get more capacity out of the battery. And of course, the other side is to use less power for what you're trying to do.
Exactly.
So I was interested. So what are we actually using in terms of current consumption? So just have a play around with. Now, I've just made this up 5 minutes ago, so I don't actually know the answer yet. But here's a Bluetooth ANC headset, and I've just taken. I'll just swing that in. Just angle that up a bit. So I just took a good old multimeter, put it into the ohms range, and put this in the path of the battery. So the battery power is actually running through this multimeter, and therefore it can detect. It can tell you how much current you're using. So it's switched off now, and it's got 0 amps being used. If I switch on the ANC, there's the ANC on there. We get about 9 milliamps just from the ANC on. Now that would vary depending on how much noise you put in. So if I just knock it around, see that ANC mic's picking up all these bumps and trying to do the feedback ANC for it, and it's spiking up 40 milliamps from that. So you can imagine the background noise, essentially, that's what it would relate to. The background noise is going to have a huge impact on how much energy you use for active noise cancelling. It's funny, back in the days when we were first starting out in noise cancelling, people were talking about if you have noise reduction, active noise reduction, you're in an aeroplane, could you end up using less power because you could listen to the music at a lower level? And from what I can tell so far, no way. You're always going to spend more power.
That's actually interesting. That's interesting because that kind of applies to all the different functions. If it's an amplifier, the more you're making it work, the more power it's going to consume. With the Bluetooth radio, they have power scaling as well. So the more body blocking or interference issues that your Bluetooth receives, the more power hungry the radio is going to be and consume more power overall. So that's
Yeah,
why they put on
exactly.
the spec sheet peak power consumption, and that's what most of the specs are based on. But that's not necessarily what the marketing document is based on. That's kind of
Yeah, so well, this
interesting.
is the thing. It's not mentioned what are the test conditions for a given battery life, so it can be questionable, can't it?
Right.
I'll put this into. It's just powered on now. You got about using about 20 milliamps. It'll jump into pairing mode in a second, or not. Okay, maybe. No, it didn't go to pairing mode by itself, but just in its standby, ready to, something can connect to it if you paired before. You're using, it's dropping down a little bit. It might have like a low power mode, drop down to 10 milliamps. What does it do? It jumps up and down a little bit. So that's interesting, but you're looking at sort of 20 milliamps. I'll put it into pairing mode. Just want to see if that makes any difference. I powered it off. Actually, interesting, once I power it off, it still sits at 20 milliamps for a little while before it drops off. Doing something else in the electronics before it actually drops back to zero. I'm not sure what's going on there. That's interesting. This is actually using a Qualcomm 3003, I think.
Something, yeah.
It went back to zero there. What we'll do is we'll jump it into pairing mode. Yeah, you're right about this power scaling thing. So now it's sitting in pairing mode. It's available for connection. It's actually using less than the 20 milliamps. So I'm going to quickly grab a phone and connect it up, and we'll see.
All right.
See what we get. This is going to be a problem because this old phone is still in pairing mode. Come on, there it is. I won't show you the the model. It's not important. Connected.
Okay.
It's connected. It's doing nothing. Let's see if we can play something. It must have something on here.
Looked like it spiked up slightly during the connection and then stabilized about 15 milliamp there.
This isn't going to work out because I don't have YouTube installed here, and let me see if I can run it. It wants to update YouTube. We might have to go for another phone that doesn't have that problem, or we'll do it slightly differently, actually. So the next thing is what I do to test the battery life is actually run the thing on a test machine. Here we go, and so the process is basically like this. I'll just disconnect it. Put it into pairing mode. I have already just loaded the Bluetooth battery life test. I start the test, so it'll connect to this device. Let me see what we've got getting there. That's good. Then it will try and set the SPL level to 80 dB. I think I've got it at 80.
Okay.
It might be 84, in fact. 84 dB average SPL level. So you're comparing everything on an equal footing. And then it'll just continue to run with pink noise until the battery runs out, basically. So you just find out in a full operating mode how long you'll actually run for. So it sits at about 20 milliamps there by the looks. It's pretty interesting. What I'll do is I'll just flip on the ANC and see how much that changes it. Yeah, you do jump up the ANC a little bit. You'd be using roughly 30 milliamps if you had the ANC on, about 20 milliamps with it off, I guess. And away it goes. Switch it off again just to see the comparison. Switch back on. Yeah, you're at about 27, 28 with ANC on and about 20 milliamp, or no, 18 with it off. So you got about 10 milliamps extra consumption with the ANC on. So if you to call that 30 milliamps, I happen to know this product has in it, where are you? There you are.
Yeah, focus.
550. 550 divided by 30. Anybody?
What, 18 or something like that? Just
Yeah,
under
something
18?
like that.
Yeah. Well, 5,
So
6.
you'd get that many hours, basically.
Wow.
So there's that. We'll just leave that to run for a while and see what happens if it just ticks away at that level continuously.
That's pretty healthy. I mean, you can just imagine people trying to remember to charge their batteries, and it's the user experience that's the challenge with all these features. You add features, people like them, and then having to recharge your device literally every day. People are habitualized with their mobile phone now, but I just believe that true wireless stereo, you forget to charge them, and then it's kind of that's why the carrying case is embedded with batteries from almost the launch of those products. I don't know if the early days of Samsung or those guys from Munich, I can't remember the name of them, that started true wireless stereo, if they had a charge case, but it was always an issue. Your power management on those devices. Bragi, those are the guys from Munich. Yeah.
If you were to ignore all other parameters and just think about it in terms of the chain of events, it first started out when you had the Nokia mobile phones, and you could get like a week out of a battery charger, at least several days. And by now that's dropped down to you're lucky to get a full day. You know what I mean? Obviously, it's doing a hell of a lot more stuff, but just in terms of how much energy is getting used from batteries is totally different. Similar things from headphones. I mean, we used to make the old battery-powered ANC headphones that you use a AAA cell in it, and you'd get 30 to 40 hours out of that. And now with Bluetooth devices with the built-in lithium batteries, you're down to something like this at 20 hours, you say 18 to 20 hours. Mm-hmm. So there's huge demands on battery power.
Right. Okay. Well, maybe now's a good time. I can talk about some new technologies that I've come across in the last year in my business travels and such. Let me talk about myself, my screen, or however we call that. So we touched at the beginning, there's some new ideas in battery technology, but it doesn't move super fast because of safety and stability in launching these technologies. A lot of it is heavily driven by electric vehicles, but here's just a couple I wanted to mention that are scalable into consumer electronics. So Adionics is a firm, they're co-located in Israel and London. And they basically take the anode cathode structure, and they have a stable way to 3D design those components of the battery so that you can reduce the charge time by half and increase the capacity by double. And basically what's cool about it is it's agnostic to the chemistry. So you could basically run any chemistry with this new battery design. They're probably about a year and a bit away from mass production, but making some good strides there with a different kind of anode cathode structure. Another companies, I should say, these guys are about 10 years old, California Lithium Battery. And these guys do a different approach. This is a chemical change approach. So it's a Silicon-Graphene structure, which is a lot of people have been working on, but these guys were the first guys to be able to stabilize it. So they worked with the Argonne National Laboratory in the States, and they were able to stabilize this new chemistry. So it's basically with this new chemistry, they're able to triple the capacity within the same size. So these are just some new kind of horizon technologies that we're watching. I think the California Lithium Battery is, I've heard about 2 years away from mass production. So those are just kind of forecasting items, but just kind of give people an idea that there are things in the work, but this space doesn't really move super fast. So just some comments around that.
Yeah, it's a big question mark over, I mean, you can keep eking a little bit more out of a lithium battery, but it's nothing revolutionary apparent, is there?
Yeah, well, there was the supposed quick charge. I'm not sure if it was Samsung and Apple, but quick charge, they basically just increased the current from 500 milliamps up to 2 amps. So that put a lot of pressure on the battery for heat and such. So both of these two new technologies we're talking about have stabilized for heat and these other issues that could cause damage and possible risk in the battery and then the device that they're within.
Just having a quick play on the side. I'm interested to see this. I'll put that into view. I set the thing to maximum volume.
Okay.
Maybe about 40 milliamps. If I turn it right down, basically to minimum volume, and then stop bumping it, turn it right down. There we go. That's with the ANC on, so it's about the same as we saw before, 25. So you've got like 15 milliamps for the music output between none and maximum, and about 8 milliamps, I think we said, for ANC, and then about 20 for just that Bluetooth system. So that's where your big budget is going into the Bluetooth system still.
Right, and that's the operative word. A lot of people talk about budget or power management or all these kind of terms when speccing out their product.
Yep.
So, okay. Well, anything else we need to add on batteries today?
I've got nothing else at the moment.
Oh, that's fine. We don't need to blather on if we got nothing else to say. So yeah, anybody got any questions or some objections to anything we say? We'd love to hear from you. Just hit a comment down below and subscribe if you want to keep up with our regular podcasts. All right, Simon, thanks for your time.
Thanks, Dave. Thanks, guys.
Okay, see you guys. Bye-bye.